Alright. What's the number one thing you have to do when dealing with inequalities when you divide by a negative? Say who cares? Flip the sign. Okay. So the direction of the sign needs to be flipped. Okay. And that's only if you divide or multiply by a negative, right? Else you treat inequalities just like equations, correct? Yeah. All right. So what we're going to work with in the next couple days is solving multi-step equations. Multi-step inequalities, which, to be honest with you, is just like solving multi-step equations. Okay, except for that one twist if we have to divide by a negative or multiply by a negative. Now, when we do these, guys, there's a lot of different kind of initial formats of inequalities that they can give you. All right? And as we do them in class, we might maybe attack them a couple different ways. But if you remember what we did in Chapter 2, and it was like Section 2.4, 2.5, we were solving multi-step equations. We did that for 3 or 4 days. Okay? And we're going to continue working on that here. Throughout all of your next 3 or 4 years of math, you're going to work with solving equations all the time. So if it's a skill that you're yet to kind of master, that's something you're going to want to get under your belt as soon as possible. Okay? I'll give you some resources here. I emailed you. And I made that thing about 9-10 years ago. So I might go back, get some of the wording. I think could be fixed a little bit. But right now, this is maybe a guide for you, okay, to be able to go through and solve equations, okay? Especially the flow chart says, ask you a simple question on the left, and you answer it with a yes or no, and then depending on whether you said yes, it'll tell you what to do. If it says no, it'll tell you what to do, okay? And over on the right-hand side, for that step, it shows you kind of what you're supposed to do, okay? So it says distribute. On the right-hand side, it shows you then the action of distributing, what that means, okay? But if you go through this, if you struggle with equations, you know you're a person that is continually getting them incorrect, this would be maybe a good place to start, okay? Use this thing right next to every question you do, okay? Sometimes you'll use every single one of those questions on there. Sometimes the answer will be a lot of no's, and it just tells you to go to the next step, okay? But that's the chart that will get you down to the right answer every single time, okay? My thought is, if you're struggling with equations, it's because you're not sure what to do, okay? If you use that chart for a series of homeworks, 3, 4, 5 homeworks, the idea then is, okay, on that 6th homework, take the chart away. And hopefully you've used it enough that you can ask those questions to yourself and progressively work through those more difficult types of equations, okay? So that's kind of what, that chart or something like that chart is governing every question that I asked you guys within these things on how to solve them. So the first thing I'm going to say is we're going to, if we go back to this chart, let me put this chart up side by side here, and we'll just look at the left-hand side.
I say that you subtract 9.
All right, so if I'm using the chart, so the chart should allow me to address any type of equation or inequality. It says, are there parentheses? Yes or no?
No.
Nope, so then it says go to next step. Okay? Part A says look at the left-hand side of the equal sign. Are there any terms that you can combine with your variable? Left-hand side, is there anything? No. Okay? If it says yes, just put them together. Pay attention to signs, then go to the chart. Okay? So now the chart says, are there any leftover terms on this side?
Nope.
Just numbers. Okay? So 9 is there, right? Okay? But I can't combine any of those, right? 9 doesn't apply. So then it says repeat part A, but on the right-hand side. So on the right-hand side, I ask, okay, is there any variable terms over there? Nope. Okay? Are there any constants over there? Nope. So now I go down to the next question. It says, are there variables on both sides? There are variables on both sides?
Wait, variables to the left?
No. So then it says go to next step. Says look at the side of the equation that has variables on it. Is there anything left on that side? Yes. Okay, so it says move it to the other side using the opposite operation. So right now we need to realize that this is a plus 9, right? So I subtract 9. Subtract 9, so I get 14 is greater than 12. Okay, so now we go back to the chart. So is the number in front of your variable an integer other than 1?
No, but the number, yes.
Yes. So that tells me divide by that number. If it was not, it'd be a fraction, and it would tell me to multiply by the reciprocal of that fraction. Okay. So in this case, it is yes. So divide by 4. Divide by 4. Oh, that's 4. And it leaves me t is greater than what? 30.
I got that.
Yes. There were. I put a couple of these on your last assignment just to see kind of where we were. For those of us that have done that assignment, it looks like I think where we need to be collectively so far. The next thing I want to do is graph this. So just remembering, okay, we had the opportunity to have open dot. Yep. And we had close. All right. All right, so those are our options, right? And we talked about the idea that in comparing, this thing doesn't work. Comparing this group there to that group there, the bottom one takes more to write, correct? Filling in the dot takes more to write, correct? Writing the word closed is more ink than open, right? All those kind of link together. So if I've got greater than in my problem, it should be open or closed. It should be open, right? So my number lines, guys, I always just find 0. And when I say find 0, I'm just going to put a hash mark somewhere and call it 0. 3 should be to this side of it, right? You said open dot, and I'm going to shade which direction?
Wait, come on. Left. Right.
I'm going to shade to the right. Okay? So that means that any number that I pick off there, what is the number that's in that range of values that I just shaded? 4? Okay, so put 4 in there. What's 4 times 4? 16. Okay. So we're at 9 plus 16. What's 9 plus 16? 25. Thank you. Okay? So I get 25 is greater than 21. Is that a true statement? Yes. Because 4 was right there. It was on that ray that we shaded. Okay? So all the numbers that we choose, we're going to change that 25. If I choose 5, it's going to give me, 29 there. If I choose 6, it's going to give me 33. Okay? But if I keep choosing larger numbers, for the right of 3, that number is going to increase. Well, a number bigger than 25 is always going to be bigger than 21, right?
Yeah.
So that's why all those solutions need to be original. Okay? Okay, next one. So I showed you how to use that chart. Okay? If you want to use it, by all means, I don't think it's something that's going to ever harm you to use that. Okay? So get down to this one. Add 7 to both sides. Try to isolate that negative 6a, right? Try to get that by itself. So add 7 here, add 7 there. So negative 6a. 17 plus 7? 24. Okay. Now what are you going to do? Divide by negative 6. And when I divide by negative 6, okay, so I get A, I get negative 4, and good. I need to flip the sign. So right now, my sign is pointing to the A side, right? So it needs to point away from that then, to the negative 4. So we're graphing that. I'll show you why in a minute. So if I put negative 4 here, open or closed? Closed because it's equality, right? Shade what way?
Right.
So A is numbers that are bigger than -4. So numbers that are bigger than -4 over there to the right. Okay? Now, the reason we have to flip that inequality sign, let's say I didn't flip the inequality sign. Let's say I left it in red. Let's say I left it as A is less than or equal to -4. Well, that means -5 should be an answer, right? If I choose -5, plug in here, I get -6 times -5 minus 7, and I ask the question, is that less than or equal to 17? Well, think about it. This is the reason why we had to flip it. What's a negative times a negative? It's actually a positive. So now I get a very large number, -7, which would be 23, right? 30 minus 7 is 23. Is 23 less than or equal to 17?
Wait, did you say what?
No, 23 less than or equal to 17. It's not, right? Okay. And the reason we have to flip our inequality is because when we come back in here and I plug a negative number in here, okay, that's going to give me a positive, and I'm not removing enough from that positive to get underneath 17. So we have to flip that inequality sign to make this original statement true. Does that make sense?
Yeah.
And it has to do, in part, essentially negative times a negative gives me a positive. Now, you might say, well, then why does -3 work? Well, -3 works when I plug it in here, because now I get -6 times -3 is positive 18, minus 7. I'm not subtracting, or I'm subtracting 7 away from a small enough number, 18. So 18 minus 7 is 11, right? Is 11 less than or equal to 17? 11 less than or equal to 17? Yeah. That's why -3 was indeed graphed on that line. Always have to remember that. Always have to put the sign when you divide or multiply by a negative. Come on, there. Next one. What do you want to do here first? Okay, here's the thought. Do what you just said. Several said add 5. You're gonna add 5 here. You're gonna add 5 there, right? They give you 1. They give you 10. Does that really get this to be a simpler equation? No. So adding 5. Not only what should we do? Subtract 5. So now I get -9, less than these cancel, -3 in, right? Now we do. Divide by -3. Okay, what's a negative divided by negative? Positive. This is going to be in, right? Now this was less than. So now I need to make it greater than this way. Is that okay? Now, I'm a fan of writing my variable first. So then this is going to change to n is less than 3. Now, the argument that people say, when you start with the less than, you still finish with the less than. Yeah, but now my variable is on a different side, correct? So I did flip it. Okay? So now, I'm going to graph that, where is, what value am I going to start at? I'm going to start at 3. Now close or open, and shade which direction?
Are you recording? I just you usually have your thing hanging up on your chest or whatever that thing is.
My chest?
Yeah.
Wow. This is better for you. It's just really loud when I put it here, when you watch the video. Alright, so those are kind of your traditional kind of one, I guess, those are your two-step equations, okay? Now, two-step is considered multi-step, but multi-step is more like these here. Okay, these are the ones that tonight's homework is going to kind of focus on. Okay? Here we've got variables on both sides, right? Okay, so what's the first thing you want to do here?
You want to add 1.
You want to add 1? That's fine.
That's what I do. If you add 1, you get 9, and then you subtract 3 in from both sides, you get 3 in, divide by 9, and you got 3.
So you get 6 in, greater than 3 in, plus 9, right? Now, continue to tell me what you're saying, Travis. You're going to do what?
Subtract 3.
Why? Why subtract 3 in? Why is that most logical?
Because you got to get 9 by itself.
Okay. Okay. So your philosophy is get this 9 by itself, which is actually going to make those two things. So subtract 3 in from both sides. We isolated our variable, right? Now you said isolate your constant, which is fine. Okay. It says really the same thing. So now you're going to do what? Divide both sides by 3. So I get n. N to be greater than 3. Okay. Now, some people might not have done that. What's another approach that we could have gone with? Lindsay? You subtracted 3 in first. So it gives me 3n minus 1 is greater than 8. And then what are you going to do? Add 1, so I get 3n is greater than 9. Still going to divide by 3, right? N is greater than 3. Is there, in my experience with students, they always want at least give me some like that worksheet, that handout I gave you in your email. That is a set of steps that you can follow to a T every single time and get the right answer. Now, as we start changing steps and doing different things, it's with the insight of being efficient in mind. Okay, or the goal of being efficient in mind. But some people say, well, I like all my variables to be on the left. So I'm going to take 6 in, I'm going to keep it there. So then I subtract 3 in from both sides, and then add 1. So that's kind of what Lindsay was telling us to do right here. Some people are under the understanding that, well, it don't matter whether I subtract 6 in or 3 in from both sides, so they do this.
Another reason why I keep the variable on the left is that way I don't have to rewrite it, because how you do it.
Okay. So now I'm going to subtract 8 from both sides, right?
Yeah.
So I get negative 9 is greater than negative 3 in. So now divide both sides by negative 3. It'll give me this, right? Now pay attention to this. I'm going to make this inequality kind of a dotted sign. Because I didn't change the sign, right? I divided by a negative 3, but I didn't flip it. Look at that red answer compared to the other two blue answers that we had. It's wrong, isn't it?
Yeah.
So you see how, if I've got 2, 3 different ways, these two ways didn't require me to divide by negative. And I know then that this is the answer. The only thing I did different here is I ended up creating it so I divided by a negative. I don't get the same answer. So hopefully that then proves to us that you have to flip that inequality sign. Okay? Now what Travis said, he's like, I like to get all my n's on the left-hand side, all my variables on the left-hand side, because now at this stage, what do I have to do? I have to flip it. I have to now write n is greater than 3, and by doing either one of these here, that kind of works its way out anyway. That kind of makes sense to everybody? All right, so as we go through and maybe do one problem a little bit different than the other, the reason is because we're trying to be efficient. My hopes are we understand you can do anything you want to an equation. You'll never be wrong. You want to add 10 to both sides of this equation right here, that's inequality, you won't be wrong by doing that. You're not going to get to the answer as fast as I will, but you won't be wrong. Does that make sense? Because you keep it balanced, right?
I get it.
All right, so what would you do first here?
I would subtract all the way top.
Say what you're going to say. No, say what you're going to say. Well, say what you're going to say, though.
I don't want to.
You're going to subtract 1 from both sides.
Yes, I want.
Okay.
I don't want to do that.
So if I do that, now here's what we got to understand. I can't subtract it from these parentheses. I got to subtract it from out here. So it's going to be 3x less than or equal to 4x minus 7 minus 1. We'll do it the more efficient way here in a moment. But I get 3x less than or equal. Now what do you got to do?
Now you got to do it.
Okay, so it's going to be 4x minus 28 minus my 1, right? So I get 3x is less than or equal to 4x minus 29. So now what do you do? Okay, so it's going to give me negative 1x is less than or equal to negative 29. Now what'd you do?
You have to divide by negative because
Okay. So give me x and give me 29, right? What do I do with that? Okay, so it's got to point to the 29, right? Okay, but what I'm trying to prove to you is that when you said subtract 1, as long as you do it to both sides, you're not wrong. You can continue to work with your math. You create something maybe you don't like the way it looks. I would argue that most people aren't going to like the way that looks.
yeah.
But as long as you do it to both sides, and you have the end concept in mind, the end concept, the end overall goal, get that thing by itself, right? Okay. So, if I started with 3x plus 1 less than or equal to 4, x minus 7, what would be the most logical thing to do first? Distribute. So we have 3x plus 1 less than or equal to 4x minus 28. Okay. So now at this stage, is that question very similar to this one here?
Yeah.
Yeah. So what do I gotta do? Annika, now what am I gonna do?
Hey, that girl used to go to our school, for real. You don't remember her?
Oh, yeah, and minus 1. Do that.
You sure?
Yes. Do it.
You're positive.
Do it.
Sure. Minus 1.
Based on everything we just said, that's what you're gonna do.
5, minus 4.
That's what I did.
Based on everything we just said, that's what you're gonna do. What the heck?
Yes.
Do you know what we just said?
I just
No, you don't. All right, so subtract 1. All right, so you get 3x less than or equal to 4x minus 29, right? Is that exactly what we have there? So I should be able then to subtract 4x. So then x will be greater than or equal to 29, right? Graphing this, open or close dot? Closed. Shade which direction?
right that way.
To the right.
Right, my bad.
Okay. All right. Yes. Sure. Positive. Okay. So we got these special cases here on the back. Okay. And these are going to pop up. There's a couple of these in your homework tonight. You don't know at the onset that these are special cases. Okay. It's not until you come to a line in your work that you start to think, okay, what are they trying to say to me here? And then you have to make an argument. You have to make a conclusion based off that. So what would be the first thing you would do here solving this inequality?
Oh, wait, no, they're not both that.
Distribute. So you get 10 minus 8a is greater than or equal to 10 minus 8a, right? Okay. Now, what would you do if I don't see anything here? Huh?
Equal to each other.
Okay, so you're telling me that there and that there are identical, right?
Yeah.
Okay, so no matter what A is, that blue thing becomes a number, right? And that yellow thing becomes a number, right? But it's telling us that those numbers are going to be
Greater than or equal to each other.
okay, great. So if I put 2 in there, I get negative 6 is greater than or equal to negative 6, right?
Yeah.
If I put 12 in there, I get, so what's 8 times 12? 96. Okay? So I get 10 minus 96, which is negative 86, right? So is negative 86 on the left greater than or equal to negative 86 on the right? Yes. So the idea is at that stage, no matter what you plug in for A, the left-hand side will be greater than or equal to, and in this case it will always be equal to, the right-hand side. So, what's that telling me my solutions are?
0.
Oh, what is that?
Well, I just said that
No.
No.
Yeah.
No.
infinite solutions.
It is?
Let's go,
I thought it was another word for this kind of thing.
Whoa, that was cool.
Huh? Say again. Yeah. So we've got infinite solutions here. Okay. Sometimes they might write solutions are all real numbers. And a more concise kind of notation to write all real numbers is to write this symbol, capital R with kind of two sticks here for the whatever you call that thing. Now that's fine that we made that there, but did anybody go further and say, well, I'm going to add 8A to both sides? You can do that. And there you get 10 is greater than or equal to 10, right? And at that stage, you might say, okay, well, no variables, nothing to put in. So then you ask yourself, is that a true statement? And if you say yes, it is, then that tells you all real numbers are solutions. You get infinite solutions. If it says no, if you get a false statement, then you say no solutions. Okay. Some people might have taken this and said, well, I'm going to subtract 10 from both sides.
I think the bottom one's,
So you get negative 8A is greater or equal to negative 8A. Okay? You can stop there and say infinite solutions, or you can divide by negative 8. If I divide by negative 8, I'm going to get A to be less than or equal to A, right? Does that make sense? So I'm just trying to give you guys different places you can stop. So you can make an argument about what's going on here. All of these are going to say the same thing, infinite solutions. So now the one on the bottom. What are you going to do first?
I added 5 to both sides.
Okay, that's fine.
I like terms.
That's fine, but yeah. The most logical thing is, but you can add 5 to both sides. It doesn't matter. But I think the safest thing is just to get those like terms to be added together. So you get one variable term and one constant term. Now what do you do?
I added 5.
Okay, so it gives me 5 and 5, so I get 6m is greater than 6m plus 12. Now what did you do? Okay, subtract 6m. What's 6m minus 6m? 0. 0 is greater than 12. That's false. So if I get a false statement, how many solutions do I have?
0.
No solutions. Okay, now, at this stage here, could I subtract 6m from both sides? Why not?
I'm just playing.
If I get 6m minus 5, greater than 6m plus 7, subtract 6m from both sides, I get negative 5 is greater than 7. Is that false? Okay. Now, why is that different than that? Well, if I add 5 to both sides, do I get the same thing? 0 is greater than 12. Add 5 to both sides, and the one that on the right there, negative 5 is greater than or equal to 7. Or sorry, greater than 7. Still false. So false means no solutions, right? Yes.
Why can't you wouldn't you add 1m to make it, or add 1m to 7 make it 8? I don't understand
Well, what you're doing there then is you'd have to add m over here too, because you're adding something new to this side.
So you would always subtract it. It's like if you're adding it in.
Yeah. So if you're working on just one side of the equal sign or the inequality sign, there you blank out like so. I'm going to cover that up. So you have 7m minus 1m. You'll condense those to 6m first. The only time that you're going to kind of do this opposite operation is if you're going to move that amount to the other side of the inequality sign. Okay, so let's I think graph this. If we were to graph this, okay, so here's my number line, right? 0. Let's put 10 there. Put 20. Negative 10. Negative 20. If I'm going to graph all real numbers, this is the way you do it. You just highlight the entire real number line. Does that make sense? Yeah. Okay. Or if you want to do it above, like we've been doing above these, you just shade the entire thing. Don't leave anything out. Okay. I want to do one more, and then you'll have a little bit of time to work on your assignment. What if I said 6m plus 3 is less than 2m plus 1? What would you do first here? Distribute, so we get 6m plus 3 is less than 6m plus 3. What did you do next? Okay, so you're saying that the left-hand side and that right-hand side are the same thing, right? So give me a value for m then. So I heard 12. If I put 12 in there, I get 72 plus 3, which is 75, right? I better get 75 the second time I do it, right? Ask that question. 75 less than 75?
No.
No. They're equal. Okay, so here's the idea. If I keep going through with this,
My bad.
whether you subtract the 6 m's from both sides first or the 3's, it doesn't matter. I'm going to subtract 6 m from both sides, so I get 3 is less than 3. Is that a true or false statement? That's false. So whenever you ask a question and answer it with false, in regards to the amount of solutions you have, that's always going to produce no solutions. Okay? Whenever I answer a question, true or false with true, it's going to give me infinite solutions. Okay? So no solutions. So how do I graph no solutions?
You just don't graph it at all.
Yeah, that's my number one. I don't graph anything. No solutions. Okay? Sometimes something you might see every once in a while, you'll see a circle with that slash through it. Okay? That means no solutions as well. Okay, it's just a kind of a quick notation way of saying it. Homework assignment, Math Excel. Remember I gave you an assignment on Friday. Some of us have not opened that yet. That's due tonight. Make sure you do that.
I got that graphic.
Good. So here's some time to work on that.
And guess what I got on it?